Okay, let's get started. So this is our first slide. Uh, Hello, I'm Pranit Jain. My roll number is this, and from the BSc Honors Data Science and AI program at IIT Guwahati. This is my submission for DA 378 in internship term project 2 course, which is in trimester 9, and it is titled by Heavy Equipment Selling Price Prediction. So as we know that heavy equipment such as excavator, loaders, etc., is resold in market frequently. Fair pricing matters for both sellers and buyers, but it's hard to price manually because there are so many factors here which interact with it, like age, usage hours, configuration, technical aspects, etc. So, what I have done is to predict target value, which is our sales price in USD for a held out test set given 100 fields per transaction. And I have choose it because it's a realistic tabular regression problem with messy real world data, heavy missingness, randomness, high cardinality, categorical skewed target, etc. So I have chosen RMSLE as my scoring metrics because it penalizes relative error, which suits right squid metric, right squid distribution. The tools and technologies that I have used are Python's Panda, sklearn, and XGBoost as the model, ridge regression, random forest, and like GBM. Let's come to our answer. My laptop is a little old, so it will need hang sometimes. Okay. I have used I have taken data from dataset from KL. I have imported some necessary libraries like in NumPy, Pandas, Matplotlib, Seaborn for the graph and images, and yeah, the models, the sklearn and sklearn and XGBoost and like GBM with the random forest regressions are used in this whole thing. First, I have loaded the dataset into a train dataset, train variable, test dataset, and test variable, and metadata and sample submission file. As we can see, this is the head of which is also on data, five rows for of dataset. This is our metadata. So, the first thing we are going to talk about is image that I have done. As we can see, there are some variables present here. So first we are going to start with this dominant. Okay. First thing that I want to know you might told you that this show the percentage of mixing values in all the columns that we can see here divided by 30, 40, 60, 80, and 100. So the more the size of this bar, the less missing values will be present in there. So in the dataset, I have noticed several spec columns had 50 to 99 missing values, and since they apply to certain equipment types, so I kept them for training models and added missing indicator flag for the key ones. As you were wondering that why I haven't dropped the greater than 50%, because even sparse column can carry signal for the subgroup of rows where they are present, and dropping will loses that. Okay, so the second thing we are going to talk about is target distribution. Uh, okay, okay. So one second, let me show you the graph one more. Okay, as price was rightly skewed, as we can see here. So I have transformed it by log 1p here, and which with because it also lines up with our RM SLE on price equal plane RMSE log 1p price. The next thing is categorical cardinality. As we can see here, that some categorical columns had a very high uh, cardinality, as we can see here. So I have used ordinal encoder instead of one-hot encoding to avoid blowing up conditions. The next thing I'm going to talk about is age versus price. Here, as we can see, there is a negative correlation between them. So I have noticed that I have derived the AZ scale, dropped impossible values such as negative or very old values, and found a clear negative correlation between the machine age and the selling price. Sorry, selling price. The next thing we are going to talk about is hours versus price. One second, operating hours versus price. So operating hours also showed negative relation with prices. So I have plotted it on a log scale since ours was skewed too. The next thing is price by group categories and utilization tier. This showed a strong price separation. So I expected them to be important features as we can see in this dot spot. And the last one, price trend over time. In this, I have checked average price by month and to see if there is any time trend to account for in our model. So the main things that we have noticed, the insights we have gained are that the target is rightly skewed, so which helps us to drop the log 1p modeling and age usage hours and uh, age price and usage hours price showed negative relation and utilization show different price differentiations like this. And so the next thing we are going to talk about feature engineering. So, okay, these are our 4 or 5 feature engineering that we have done. Okay. Uh, since some columns were missing, not random, it was applicable to certain equipment types. So I have added missing flags and for operation utilization as by tires. And the model can use was this missing itself as a signal, not just impute it away. We'll see it in further in pre-processing and etc. steps. So first, what we have done here is uh, um, what do we say? Uh, Focusing on trend. Okay, so since we have saw in EDA that price trend over time in EDA, I have broken the transaction date into sale year, month, day of the week, as we can see here, because tree structure can't use raw data time. So this helps the model learn from any seasonal or yearly pattern. Was the first feature engineering that we have done. Now, the second feature engineering that we have shown that we have know that relation between age and price was strongly negative. That's why I have engineered here age at sale equal to year minus manufacture year. So, and I have removed any impossible values and clipped it between 0 and 60. Okay. And to remove any data errors. And the next thing we have done is hours price correlation, as we can see here. I have used hours per year is equal to operation hour meter upon age itself, which give us usage intensity because intensity matters. So let me give you an example. A young machine which is lightly used and sorry, a young machine which is heavily used and an old machine which rarely used. Okay, they shouldn't be compared same. So this was all the feature engineering that we have done. The next part is the preprocessing pipeline, as we can see here. I have separated target value and transaction ID, so neither leaks into the feature set, as we can see here first. Second thing, since I saw high cardinality categoricals in EDA, I used ordinal encoder instead of one-hot encoder to avoid blowing up dimensions, as we can see here. And one more thing that I have told you that we have set the sorry, one second. Let me. Okay, I have filled categoricals NaN with and missing string itself before encoding, so that missingness become its own learnable category. You know, consistent with missing indicator flags added during feature engineering, as you can see here. And I have set the following. This encoder is equal to ordinal and complete unknown value is equal to -1. Because if there is any category that is not seen in train but present in test, to prevent breaking it, it just get encoded as -1. And the next thing we have done is numeric interpretation, as we can see here. So for numeric interpretation, I did the missing values with median values, as we know that median is more robust to skewedness than mean. And both the encoders and median values are fit only on train and reused on test to avoid any data leakage and keep validation honest. The next thing we are going to talk about are the models that we have made. So the first model is Ridge, which is a linear regression with L2 regularization alpha 1.0 to control the shrinkage. I have used it as a fast baseline model. It underfit here, as we know that price depends on nonlinear interaction, so it's true. The second model that we have made is random forest regression, as we can see here. It is a bagging method. Many trees are trained independently and bootstrap sample, then averaged. So if there is any overfitting, then we can decrease the depth or increase the min sample width. And this model showed us the score of 0.2 to 5. The next thing we have made is XGBoost. So as we can see here, XGBoost, as we know that XGBoost is a boosting method. Trees are built sequentially, uh, each correcting the previous one's residual error. And I have tuned it with random search CV instead of grid search. In random search CV, combos are we have taken random hyperparameters combos instead of taking them all, like grid search CV, which helps us, which makes us it much cheaper. And these are the hyperparameters that we have used. Next thing is the LGB, sorry, light GBM. Yeah, this is also a boosting method as a XGBoost. But in this, the tree grows leaf-wise instead of level-wise. It is faster, but it can overfit more easily on smaller or noisier data. So this was our four model, giving us different scores, which is first one have given us 0.47 something. One second, let me show you. Yeah, as we can see here, 0.4705. The second model has shown us 0.2254. The third XG boost has shown us 0.20720. Yeah, so you can see 0. One second. 0.2074, which is tuned. Okay. Now the last one is light GBM, which has showed us 0.2346. So this is our model comparison, as we can see below here. It as we can see here, the XGBoost is 100% more efficient than the 3G education. So the final metric was RMSLE, computed as RMSE on log 1 plus price scale. The best single model was XGBoost tuned, which is 0.2074. Best overall we have done is 5-fold blend, as we can see here. We have used K-fold here, and we got 0.2034. So this was all. So as in a summary, that I want to tell that I have built and compared four classical machine learning models on a real world messy tabular dataset, which is tree based models, especially XGBoost, clearly beat the linear baseline, and K-fold CV plus blending gives us a modest further improvement. The honest limitation that I like to mention is that hyperparameter plays was very light in my model. I want to make it more tuning is required, and I have learned that real datasets are more challenging than the ones I have tried to model. So I want to practice more on this real time datasets. And thank you. That was all for my project.